Good morning. We're going to talk about 6.1, perpendicular and angle bisectors. You will need the notes provided for you and then a highlighter and pencil. This is over 6.1, perpendicular and angle bisectors. And so we're going to break down those words, talk about what they mean. In 3.4, you learn that a perpendicular bisector of a line segment is the line that is perpendicular to a segment at its midpoint. So a line that is perpendicular to a segment at its midpoint. So you're going to take your highlighter and highlight this line. Basically, the perpendicular bisector cuts through the midpoint, and I know P is the midpoint because of these dashes. It means the length of AP is the same as the length of PB. And the bisector and the segment make 90. So that makes it a perpendicular bisector. It says in your notes, a point is equidistant from two figures when the point is the same distance from each figure. So a point is equidistant is your first blank, equidistant, when the point is the same distance from each figure. If you look at my picture, this is a perpendicular bisector in real life, or just perpendicular in general, because in order for a volleyball net, maybe you can see it, maybe you can't, in order for a volleyball net to properly work, it needs to be perpendicular with the ground. And although this is not a great angle, these stakes where they hold up the net, they're going to be the same distance to the pole. Again, not a great angle for that, but this is the idea of a perpendicular bisector. So, we're going to learn a property about the perpendicular bisector. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So I highlighted those fill in the blanks. Some of them are larger than others, the blanks. It is what it is. So again, in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the points on the segment. So, in our picture, I'll kind of decipher what we're talking about. Here is the perpendicular bisector. Again, it cuts through the midpoint. I know that because of these dashes, and is perpendicular as well. So what this is saying is that the distance from A to C is going to be the same as the distance from C to B. Okay, so I would mark that on your page with the two dashes or something to that extent. The converse is true as well. We'll let it highlight. Here we go. In a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So basically, if you want to know if a point is on the perpendicular bisector, the point needs to be equidistant, so equal in distance, to the end points on the segment. So point D is on the bisector in our picture because DB is the same length as DA. So it's perfectly in the center, which means if this line kept going, it would run into point D. We'll go ahead and flip. You'll see a blank. This is pretty much the entire theorem about perpendicular bisectors. So we're going to use this on this page. The point on the perpendicular bisector is equidistant to the endpoints. If I were you, I might highlight the entire phrase because this will help us solve the bottom 3 problems about perpendicular bisectors. Okay, so I'll give you a second to write that in. We're going to highlight our perpendicular bisector. So ZY is my perpendicular bisector. Perpendicular bisector. And it does tell me that in the directions. ZX is the perpendicular bisector of WY, so that means if it's the perpendicular bisector, it means WX and XY are congruent because it bisects the line. So we're going to use this information. It says YZ is 13.75, and then to find the length of WZ. Remember that when there is no line above 2 letters, it means length of. So we want to find the length of WZ. Well, if you remember the property, if a point is on the segment bisector, which Z is on the segment bisector, it is equidistant to the 2 endpoints. So if YZ is 13.75, that means WZ is also 13.75. So there's our answer. The next one says ZY is the perpendicular bisector, so we already got that written. Then it says WZ is 4n minus 13. So from W to Z is 4n minus 13. And YZ is n plus 17. Find the length of YZ. Well, I know that the length of WZ will be equal to the length of YZ. So I'm going to plug in their lengths. We said WZ was 4n minus 13. So 4n minus 13. And then I know YZ is n plus 17. Alright, so then we're going to solve. Solve for n so that we can find the length. We're going to move our smaller n, which would be n. Subtract it on both sides. 4n minus n is 3n. Minus 13 equals 17. I'm going to move this over and bring my equation up here. Right now we have 3n minus 13 equals 17. We want to get n by itself, so we need to add 13 to both sides. 3n equals 30, so n equals 10. Alright, once we have n, we actually want to find yz. So earlier we found yz was equal to n plus 17. So instead of n, we're going to plug in our n, which is 10. 10 plus 17 is 27. So yz equals 27. Alright, the last one, I'm going to erase the picture so that you can see better. I'm going to plug in what they gave us to find WZ, WX. That's what our final answer should be. When WZ is 20.5 and WY is 14.8 and then YZ is 20.5. So we want to find WX. Well, if you remember, this is a perpendicular bisector, which means it cuts the segments in half. If the full length of WY is 14.8. That means this will be half of that. So half of 14.8 will be 7.4. That's it. We move on to angle bisectors. Angle bisectors. In section 1.5, you learned that an angle bisector is an array that divides an angle into two congruent adjacent angles. Let's go ahead and fill in those blanks. So from there, it says you also know that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So here is why it is that way. If you wanted to find the distance from the point to the ray, it's perpendicular, because if you're finding the distance to something, you go straight there. You need to find the shortest distance, okay? And in order to do that, it's a perpendicular segment. So, what you're going to do with your highlighter is highlight AD, which is your angle bisector. And I know that because these marks at the bottom show that the angle has been cut into two congruent and adjacent angles. Okay, so that's what your segment bisector does, or your angle bisector. So we're going to see the theorem. It's very similar to the perpendicular. If a point lies on the bisector of an angle, then it is equidistant from the sides of the angle. So basically, so go ahead and write that in. If a point lies on the bisector of an angle, then it is equidistant from the sides of the angle. So again, AD is your angle bisector. And from the point to the angle is equidistant. So that means BD is the same length as CD. So I'd go ahead and write those in, those little dashes. So if BD was 5, that means CD is 5. If BD was 20, that means CD is 20, and so on and so forth. Okay? And again, this picture shows it's an angle bisector because of these arcs. They're congruent. These two angles are congruent and adjacent. The converse is true as well, which is the next fill in the blanks for you. If a point is on the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector of the angle. So if these are already marked congruent, that means you have an angle bisector, and that means the angles will be congruent. So basically, if your angles are marked congruent, that means you could mark the distance from the point to the sides congruent. If your sides, or from the point to the sides are marked congruent, that means these two angles will also be congruent. So, we're going to use that in the next portion. We'll flip the page. Again, this is the main point. The point on the angle bisector is equidistant to the angles raised. So we're going to use this. The point on the angle bisector is equidistant to the angles raised. We're going to use this to solve a couple problems. So it says BD bisects. So go and highlight it. This is the angle bisector, which means my two angles are congruent. I'm going to go ahead and mark those as well. Because those angles are congruent, from the point to the rays of the angle are also congruent. So let's find out what we need to look for. It says DC. DC is 6.9. Find DA. Well, this is very easy because DA is congruent to DC. So it'll be 6.9. Move on to number 2. Still says BD bisects ABC. AD, let's see what it says. AD is 3z plus 7. So AD is 3z plus 7. And then CD is 2z plus 11. Find CD. So what I know about these two things is that the length of AD is equal to the length of CD. So I'm going to plug them in. So the length of AD currently is 3z plus 7. The length of CD is 2z plus 11. To solve, we're going to move the smaller z. So subtract 2z from both sides. On the left, we will have 1z, which will write z, plus 7 equals 11. Last step is to subtract 7. So z equals 4. It didn't ask what z was, it asked what CD is. So we're going to plug in. CD was 2 times z plus 11. So we'll plug in here. 2 times 4 is 8, plus 11 is 19. So CD equals 19. Alright, our last problem. I'm going to erase what we've got because there's a lot going on over here. Our last problem, we have AD is 3.2. CD is also 3.2. So that means these are congruent, which means my angles will be congruent. It says find the measure of ABC if the measure of DBC is 39. So if this angle is 39, we know they're congruent, so my second angle is 39. So the measure of angle ABC will be 39 plus 39, which would be 78 degrees. Alright, this last section, we're just going to talk about the differences between a perpendicular bisector and an angle bisector. So if you look in these pictures, your perpendicular bisector, I'm going to go ahead and highlight it for you. It is perpendicular at the midpoint. So go ahead and write in those dashes. It means Q is the midpoint. So the property that we learned about it is that it is equidistant from the point to the endpoints. So from S to P is the same as S to R. You can see that in the picture with the 13s. Whereas an angle bisector, I'll highlight that as well. An angle bisector cuts an angle in half. And this time, from the point to the rays will be congruent. So that's why we have 7 and 7. So equidistant from the point. So here it's point J to the rays. So JG and JH are both congruent to each other. Some other differences. Perpendicular bisector is perpendicular to the segment. An angle bisector is perpendicular to the rays. So if you look, these right angles are sitting on the rays of the angle, whereas perpendicular bisector, it is perpendicular to a segment. So something else you can look for, perpendicular bisector has one right angle. Whereas an angle bisector will have two right angles in the picture. The last two things we're looking for, perpendicular bisector looks more like a triangular figure. You've got a straight line, a line above, it looks kind of like a tent. Whereas an angle bisector will look like a diamond overall, because you will have an angle, and then in order for you to find the distance from the point to the rays and be perpendicular, it will look more like a diamond. Because on your quiz you'll be asked, do you have a perpendicular bisector or an angle bisector? Sorry if you hear my child. Can you say hi?
Hey.
Hi. Do you want to watch Moana? Sorry guys, I'll pause. Alright, this last section, we're going to decide whether the following diagrams are of a perpendicular bisector or an angle bisector. Then we're going to highlight them. So this is the bisector, and we'll talk about what kind it is. So you really want to ask yourself, a perpendicular bisector is equidistant to the endpoints. An angle bisector is equidistant to the rays. Alright, so in our first picture, we have point N on the bisector. It is equidistant to what appears to be endpoints. So this is a perpendicular bisector. Letter B, this is the bisector. Right here, we need to decide if it's perpendicular or an angle bisector. It looks like from the point on the bisector to two rays are congruent, so that makes this an angle bisector. Also, it looks more like a diamond. And again, the perpendicular bisector looks more like a triangle. Letter C, we have a bisector cutting through a line segment. So this is a perpendicular bisector. Because it is equidistant to the endpoints on the segment. Letter D, go ahead and highlight that bisector. This one should be fairly easy. It's got these two marks, which means your angles are congruent, which means the angles were bisected. Next one is very similar, just turned upward. Got these two marks, which means an angle was bisected. Letter F, last one. We've got this bisector. It is equidistant to the end points. So that means this is a perpendicular bisector. That's the end of 6.1.